students. Today we are going to see the topic about shear force diagram and bending diagram in overhang beams. Previously, we have discussed about what is shear force, and what is bending moment, and what are the different types of beams, different types of loads, and how to evaluate or how to plot the shear force diagram and bending moment diagram for the different types of beams. Okay. So already we have come across the single supported beam. So in which we have plotted the shear force diagram, bending moment diagram, and we have also uh, determined the maximum bending moment in the maximum bending moment for the simply supported beam, and also we have identified how we have determined how to find out the location of the maximum bending moment, how to evaluate the maximum bending point. So in this class, so we are moving on to the another problem. Okay. So which since what has been completed in the previous lecture classes, and now we are going to the how to plot the shape and minimum diagram in the overhanging beams. Okay. So first of all, we should know about we are know about the what is the overhanging beam. Yeah. The overhanging beam is extended beyond the support. So that is known as a overhanging beam. So in this we are going to plot it. We are going to determine the distribution of the shear force at the moment. So we can get into the problem. So this is the problem we are going to solve today. So draw the shear force diagram and bending moment diagram and locate the point of control fixture for the beam given in the figure. Okay. So already we have seen how to evaluate the shear force and bending moments in the simply support beam. In the same procedure we are going to follow, and additionally we have discussed about the point of control fixture. Point of control fixture is the transformation of or the transition of the bending moment from the positive to negative or vice versa. So this is known as the point of control fixture, and we have to determine the location and what is the location of the control fixture point. Okay. So that is the point of control fixture on this. So that we are going to determine. Okay. So this is the given coded beam section. Yeah. So in this there are two supports are there, namely A and B. So this is support A and this is support B and this is support C. Okay. So A and B is support. A and B are the two supports, and from the right support B, the beam is extended up to a certain length, 1 meter, till C. Okay. And the beam is loaded as shown in the figure. The beam is entirely loaded to about the 2 kN per meter for the uniformly distributed load, and uh, over a length of 3 meter, and another one point load is there. So that is about 2 kN magnitude is at point C. So these are the two loads acting on this overhanging beam. Okay. So we are going to solve for this loaded beam, and we are going to plot the shear force diagram, minimum diagram, and we are going to evaluate the point of control picture for this loaded beam. So first we have to find out the support reaction. For the support reactions, we have to identify the for the support reactions. So we have to uh, go for two equilibrium conditions. We already, which have previously in previous classes we have done also. That is, the summation of the shear forces is equal to sum of the forces acting on the beam is equal to 0, and summation of moments about the point is equal to 0. So we are considering about the left support. So and we are equating the forces. So the support reaction. Yeah. So this is the beam we are have been loaded, and this is one support, at A, this is A, and this is another support at B. This is entirely loaded with an UDL of 2 kilonewton per meter, and there is a point load is there. So it is also having the same magnitude of 2 kilonewton per meter, 2 kilonewton. So that is 2 kilonewton for the point load. And this location is C. So this is a B to C is an overhanging section. So first we are going to find out the supports. So what are the loaded beam? How the supports has been load has been shared. So that we are going to be analyzing. For that we are going for the two equilibrium conditions. One is sigma F is equal to 0 and another one is sigma MA is equal to 0. That is summation of all forces acting on the beam is equal to 0 and the summation of moments acting on the beam is equal to 0. So from this consideration we are going to evaluate these two unknowns RE and RB. So here we are taking the positive sign as upward direction and negative sign as downward direction. So the from upward acting forces are known as the positive sign. We are considering as a positive sign, and downward direction acting forces we are considering as the negative sign. So first from the left support we are moving. So here RA. So first from the left support there is a support is there. So that is acting in upward direction. So we are mentioning it as RA. Then there is from next there is a load is there. That is a uniformly distributed load is given. So uniformly distributed load is given to a length of totally between the supports the length is 2 meter and extended B to C that overhang section is 1 meter. So totally 2 meter. 3 meter the entire UDL is acting. So here it is 6 kilonewton. The load is converted into the UDL is converted into the point load. Then the total load value is this UDL value into the load acting distance. So then convert into force that is 6 kilonewton. Then there is a downward action force is there. So that is 2 kilonewton. Then support is RB that is moving up acting on upward direction. So that is RB plus RB. So this both the forces are in acting towards the downward direction. So we are mentioned this negative sign. So resolving this RA plus RB is equal to 8 kilonewton. We are keeping it as equation number 1. Simultaneously, next step is the summation of moments we are calculating. Summation of moments. So about the point A only we are calculating. So from point A, so first is we are considering the clockwise direction is positive. Clockwise is positive and anti-clockwise is negative sign. So for clockwise direction, the moment about clockwise direction is positive sign and anti-clockwise direction is negative sign. We are assuming. And from A point, so B is producing anti-clockwise moment. So B is at a distance of here it is RB, force is RB, and support reaction is RB, and it is from A it is about 2 meter distance. So it is producing anti-clockwise moment. So we are mentioning it is a minus sign RB into 2. Then a point load 2 is acting at a distance of from point A it is a distance of 3 meter. So 2 into 3. Then this UDL. So UDL is equal to so this 2. So we all know about how the distance we are calculating. So first we have to convert into the so 2 into 3. So this is first load. Actually the moment is the formula is force into perpendicular distance. So the UDL is resolved into force by multiplying it with the total distance. So 2 kilonewton force acting for a distance are 3. So force into distance, we will convert into the net force. Okay. Then in distance, that is the UDL will be acting at the midpoint of the total UDL acting distance. Total UDL acting distance, and this is 3 by 2. So that is 2 into 3 square divided by 2. So that will be equal to 9, and this will be equal to 6, and this will be equal to minus 2 RB. So totally, after resolving, it will get RB value is equal to 7.5 kilometer. The simplified calculation. Then substitute RB in RA. This equation number 1, we can get RA is equal to 0.5 kilometer. So this is the common resolving, and we are getting the values. Then from this, after the next step is we are going for the shear force calculations. So shear force calculations simultaneously we have seen many problems in our lecture classes. We are going simplified manner. So shear force we are cumulatively adding up. So shear force at point A is this 0.5 kilometer. What you have find out. Then shear force between A and B. There is a UDL is there. So UDL is extended between the 2 meter. So minus 0.5 into 2 into 2, 4. That has been given. Here also we are consider first consideration is sign positive is upward direction, and negative sign is downward direction. Okay. So from this we can easily resolve the forces. So here R is acting for upward direction, so we can mention as a positive sign, and this UDL between A and B is okay acting in a downward direction. So 0.5 minus 4. So the comment is shear force between A and B is minus 3.5 kilometer. Okay. The shear force between B at B there is a upward force is acting, support reaction is acting. So minus 3 point, actually this value will be coming here, and you have to add this upward force plus 7.5. So plus 0.5 we will get 4 kilonewton. Then again there is a UDL between P and C. Okay, so the UDL about distance 2, and it is acting about distance 1. So 2 into 2, 2 into 1 we get minus 2. Actually this 4 will come here, then minus 2. So that is 2 kilonewton. Then shear force at C is equal to 2 kilonewton. Shear force T is equal to 2 kilonewton is there. So 2 minus 2, so it will come to that 0. Okay. So simultaneously bending moment also given here. On the supports, always the bending moment will be equal to 0. So that has been mentioned. So bending moment we have been calculated, and the values are given here. So bending moment value at A is 0 kilonewton, because at the support it is 0. From B it is again minus 3 kilonewton meter, and bending moment at C is equal to 0 kilometer, that is 0 kilometer meter. And we have to find out the point of matter of experiment. Okay. So now we have derived the shear force diagram, shear force values and bending moment values. So next we are going to plot the shear force and bending moment diagram. Okay. So this is the shear force and bending moment diagram. Okay. So what we have plotted here. So shear force value at we have to plot the beam section. Then we have to distribute the loads, and next we have to mention the scale. The scale 1 centimeter is equal to 2 kilonewton. Okay, so the first we are plot the shear force diagram. Okay, so from A, it is a upward direction. It is a positive sign of 0.5 kilometer, and between C, okay, so between A and B, so there is a UDL is there. So for this, the load is varying from 0.5 to minus 3.5. So that has been directly come over here. So because UDL is there, the line will be a slant line, and it transfers from the positive region to negative region. So this region will occur for the maximum bending region for the transition of the positive side. And the next is at B there is load is 7.5 kN. So minus 3.5 to 7. So plus 7.5. If we give the 4 kN, it rises up to the shear force at support B. It moves to the transition from the positive to shear force transfer from the negative to positive. Okay, and then between B and C there is a udil is there. So that has been drawn as a indicated here. Then at C it is a 2 kN force. Okay, so this is about the shear force diagram plotting. Then again bending moment diagram. So we are providing a scale and 1 centimeter is equal to 0.5 kilonewton meter, and at A it is 0, and it starts from between A and B we have to plot, and between B and C we have to plot. So between A and B values we have to mention, we are finding out here maximum bending moment. We have to find out the transition stage and we have to find it out. And in previous class simply supported beam part we have resolved. Let's see. Then again it is in the positive region. We will plot over here. The maximum bending moment will be here. Here only we have to indicate. So this is what we have indicated. And next, the negative side, the maximum bending moment will at the B point. Okay. So that we can discuss in the classes about this. And we have to find out the point of contraflexure. The point of contraflexure is where this point is getting 0. So the transferring from the positive to negative. Okay. So from there we have to calculate the moment. So mark this distance as x, and from where we have to calculate it. So we calculated that it will indicate as a y is equal to 0.5 meter from A. So it point of contribution located as a zero point 0.5 meter from the left support of A. We have been find out. Also we have calculated the maximum bending moment also. So maximum bending moment occur at this place. So at this place maximum bending moment is 0.0625. So that we have been find out here. That is a location where the shear force is getting 0. So that finally the minimum will be maximum. So already we have found in the that we have already seen in the simply supported beam the same procedure what we are going to follow. So we have followed it here. So refer our simply supported problem which has been uploaded in classes. Okay. So I hope you all understand about the this overhanging beam problem. Already we have discussed in the classes very frequently, and we have discussed about the assignment what you have done. If you have any doubts, kindly ask me. We can clear it. Thank you so much.